Today, we're embarking on what is, for all intents and purposes, an impossible journey. We're going to see the unseeable and try to understand what lies thousands of kilometers right beneath our feet. Yep, we're heading to the center of the Earth.
And that brings us to the real puzzle, doesn't it? We've managed to map the inside of our own planet with some pretty incredible detail. But how? I mean, it's a place with pressure and heat so intense we can never, ever physically go there. So how on earth did we draw the map?
Okay, so before we get into the how, we really need to wrap our heads around the sheer scale of this challenge. You have to appreciate just how impossibly out of reach the Earth's interior really is. Take a look at this number, over 6,000 kilometers. That's the distance from where you are right now, straight down to the very heart of our planet. It's an almost imaginable depth. And now look at this, 12 kilometers. That's it. That's the deepest hole humanity has ever managed to drill. It's called the Kola Super Deep Borehole in Russia. A huge achievement for sure, but that's less than 0.2% of the way to the center. It's basically nothing.
So what this means is that all of our direct observations, all the stuff we can physically touch and see, are just tiny, tiny pinpricks on this giant globe. You know, even the deepest gold mines in the world only go down about 4 kilometers. We are quite literally just scratching the surface.
So, if we can't drill to the center, and we can't just mine our way there, how in the world do we see inside? Well, we had to get clever. We had to figure out how to listen to the Earth itself. And our number one tool, believe it or not, isn't some super advanced drill. It's a completely natural event, the earthquake. You see, these aren't just destructive things that happen on the surface. They are moments when the planet sends out a signal from deep, deep within.
Probably the best way to picture this is to think of a medical ultrasound. That sudden blast of energy from a quake sends powerful seismic waves vibrating through the entire planet. And just like an ultrasound, those waves carry back all sorts of information about the different materials and layers they travel through. Okay, so the planet is sending out these signals, but how do we actually read them? Well, it all comes down to decoding the language of the Earth. And that means understanding the two main types of waves that travel right through the body of the planet.
Now, this is where we find our first huge clue. We've got two kinds of seismic messengers. First, you have P waves, or primary waves. They're the fast ones, and they can plow through just about anything, solid, liquid, or gas. But then you've got S waves, or secondary waves. And here's the critical detail. They have this side-to-side motion, and they can only travel through solids. The second they hit a liquid, poof, they're gone.
And that one single difference, that little fact that S waves can't pass through liquid, that was the key that unlocked the single biggest discovery about our planet's hidden interior. It was a discovery made not by seeing something, but by noticing what wasn't there.
So the big breakthrough happened when scientists started tracking these waves with seismographs placed all over the globe. They detect a big earthquake on one side of the planet, and then they listen for the echoes on the other side. But they started noticing something really, really weird. They found this massive shadow zone, a huge band on the opposite side of the planet, where the S waves just vanished. The P waves would come through, no problem. But the S waves, they were nowhere to be found. It was as if something deep inside the Earth was casting this enormous seismic shadow. And that was the aha moment. The light bulb went on. There was really only one logical explanation for this giant shadow. Since we know S waves can't travel through liquid, their disappearance was stone-cold proof that the Earth's outer core had to be a massive sphere of molten liquid metal. Absolutely brilliant. So by carefully decoding all of these seismic echoes, tracking exactly where waves sped up, where they slowed down, where they bent, or where they disappeared completely, scientists were finally able to piece together a complete, layered map of Earth's interior. And here it is, the whole picture built from those echoes. We live on the super thin, solid crust. Below that, you've got the enormous mantle, a vast region of semi-solid rock. And then, right at the center, you have the dense core, made mostly of nickel and iron, what geologists call knife, with that liquid outer layer and a solid inner core.
Now, let's just refine that a little. The solid ground we live on isn't just the crust. It's actually part of a bigger, more rigid layer called the lithosphere. This is the layer that's broken up into those massive tectonic plates that are constantly, slowly, grinding against each other.
And what are those massive plates floating on? Well, they're cruising on top of this layer here, the asthenosphere.
It's a weaker, hotter, more plastic-like part of the upper mantle that behaves kind of like thick honey, allowing the continents above to just drift across the planet's surface over millions of years.
But for me, the most mind-bending part of this whole story is the very center, the inner core. Get this, it's as hot as the surface of the sun. It should absolutely be a liquid, maybe even a gas, but it's not. The pressure from the weight of the entire planet bearing down on it is so immense that it literally squeezes the atoms back together, forcing them into a solid state. Just wow.
So we've mapped this deep, hidden structure. But this isn't just some academic exercise. Understanding this layered interior explains almost everything that makes our world a dynamic, living planet. It's the engine that runs the whole show.
Seriously, think about it. That churning, liquid outer core, that's what generates our planet's magnetic field. It's like an invisible shield protecting us from being fried by solar wind. The slow, creeping movement in the mantle, that's what drives plate tectonics, building our mountains and shaping our continents. And that same mantle is the source of all the magma for volcanoes. Our world is literally being shaped from the inside out. So we'll end on this final thought. The deep interior of our world isn't static. It's a dynamic, heat-driven engine. But all engines eventually run out of fuel. The living, breathing geology of our world is all powered by a finite source of heat deep within its core, and it is slowly but inevitably cooling down. Makes you wonder, what happens when the engine finally stops?